Yes, hi, this is George Larakis again, and today I will be talking about the fundamental theorem of calculus. I will be following the course outline from Concordia University here in Montreal, Canada, for course Math 205, which is integral calculus of a single variable, or calculus 2. I'm doing section 5.4 actually of the course outline, and I will be doing problems 3, 11, 13, 29, 43, 47, and 51. So let's state the brief theory about the fundamental theorem. So, fundamental theorem has two parts. The first part is that for any function which is continuous in a closed interval from a to b, so for any such function g of x with x between a and b, we have that g of x, if g of x is equal with a definite integral from a to x of ft with respect to t, then the g prime of x is equal with f of x. And the second part of this theorem is that the definite integral of f of x from point A to B is equal with the capital F at B minus the capital F at A, where f is the antiderivative of the function lower f of x, which briefly the second part means that when you want to find the definite integral, you just find the antiderivative and then you evaluate it in the end points and you subtract it. So now let's start with the problems. So first problem is to find the definite integral. So the first problem we said is problem number 3. So, and it's to find the definite integral from minus 2 to 2 of 3 over x minus 3 in the fourth with respect to x. So, and actually they start with the most let's say complicated problem, and I will tell you why this is a bit complicated. It's because I mean, of course, when we do these problems, we assume that we can use all the material that we know up to now, which means that you can use the rules of integration, like the integral of x to the n is x to the n plus 1 over n plus 1, etc. So now here the problem is that on the denominator you don't have just an x to some power, you have x minus 3 to the fourth power. So here what we should do for the beginning, just let's find the integral without the limits. So let's find the integral of 3 over, let me get another pen. So let's find the integral of 3 over x minus 3 to the fourth with respect to dx. So here what we should do is we should substitute u is equal with x minus 3. So, and then if you take now here the derivative of d u over dx, so which is the derivative of this with respect to x, so that should be equal with 1. So from this you get that du is equal with dx. So if you go back to the integral, you have 3 over, and we do the substitution, so we substitute wherever x minus 3 is equal with u, and whatever dx, we said here that is equal with du. So now this here, it's of the form that we know how to calculate. So this is actually the integral of 3u to the minus 1. Excuse me, this here is u to the 4, sorry. So this is to the minus 4 du. And what is the integral of this? The integral of this is 3. And here we're using the formula that the integral of x to the n is equal with x to the n plus 1 over n plus 1. So that means that this here, the integral of u to the minus 4, it will be u to the minus 4 plus 1, so that's to the minus 3, over minus 4 plus 1, so it's minus 3. So that cancels with this. And now, this here, of course, we can write it as minus 1 over u to the third. So, and now we can go back and substitute whatever u equal with x, and that should give us that this is equal with minus 1 over x minus 3 to the third. So, and now that we calculated this here, we can go and make the substitution to the definite integral, and we use the second part of the fundamental theorem of calculus. So that means that, let's erase here. So we know that the integral of this, the antiderivative of this, so like the capital F, it will be minus 1 over x minus 3 to the third. So, and if you apply now this here, so that means that you have to evaluate it at the upper limit, which is 2. So let's evaluate it to see what happened. So that means that, this is, let's say, the capital F of x. So you evaluate it at the f of 2. So if you evaluate it there, what it will give you? It will give you minus 1 over 2 minus 3 is minus 1 to the negative, to the third power, so that's negative 1. So it's negative 1 over negative 1. So that's 1. And then if you evaluate it at, let's say you evaluate it at the point minus 2, which is the lower limit. So that should give you f capital at minus 2. So that should be equal with minus 1 over minus 2 minus 3. So that's minus 5 to the third. So that should be equal with, that should be equal with minus 5 to the third, so that's 125. So this is minus 5 to the third is minus 125 with the minus 1, so that should be minus 1 over minus 125, so that's actually equal with 1 over 125. And now if you go and you substitute it, you will find that so you will find that the f of 2 minus the f of minus 2, it should be equal with the f of 2 is 1 and the f of minus 2 is 1 over 125. So if you put everything under the same denominator, that should be 125 minus 1, so that's 124 over 125. So that's about problem number 3. Anyway, in the next topic you will learn about the way of doing problems like this using some method. but for now, that's how you will do it. So let's continue to the next problem. So next problem is problem number 11. So which is to find the definite integral again from pi over 4 to 3 pi over 4 of the function cosecant theta times cotangent theta with respect to theta. So I mean that's pretty easy, because I mean from the previous section we know that the integral, the antiderivative of this is the antiderivative of this is, I mean, we have to use the formula that the integral, the antiderivative, I mean, what's the difference between the antiderivative and the definite integral is that the definite integral has limits, okay? So we know that antiderivative of cosecant kx times cotangent kx with respect to x, that's equal with minus 1 over k cosecant kx plus c. I mean, this is again is because we're talking about antiderivative. So I mean, here if you compare this formula with this formula, your k is 1, so that means that applying directly this, the antiderivative of this here, it should be 1 minus 1 over 1 cosecant of theta. So you have to evaluate that at 3 pi over 4 and at pi over 4, so that means that you have to take minus 1 over 1 is minus 1, so minus the cosecant of 3 pi over 4 minus the minus cosecant of 3 pi over 4, excuse me, pi over 4, sorry. Cosecant actually is equal with 1 over sine, so we're trying to find the, so we have to find the sine of 3 pi over 4. I mean, for this you can use your calculator, but let's find it somehow manually. So if you just do the unit circle, so 3 pi over 4 is, it's actually here, so that's actually the angle 135. So, and the sine of this is here, so it's positive. So here we measure the sine, and here the cos, so the sine is positive. So, and it's actually sine and cos of the angle 135 is the same arithmetically, so it's square root of 2 over 2. So, square root of 2 over 2. So that's the sine. So this here is the 1 over sine, so that should be 2 over square root of 2. So, and with the minus in front that we have here, so that's 2 over square root of 2. Now the minus is plus. Now the cosecant of pi over 4, it's also, it's again, this is pi over 4 is 45, so the sine of it is square root of 2 over 2, and because it's 1 over, so that's plus 2 over square root of 2. So this cancels with this, so this gives us 0. Now, let's go to the next problem. So next problem is problem it's problem 13. So problem 13 is to find again the definite integral from pi over 2 to 0 of the function 1 plus cotangent of 2t over, cos of 2t over 2 with respect to t. So, I mean, again, the main task is to find the antiderivative of this. So let's find the antiderivative of this. So the antiderivative of this, it's 1 plus cos of 2t over 2 dt. So that should be equal with, I mean, we can take the 1/2 outside because it's a constant from the rules of integration. And now you have the integral of 1 plus the integral of cos of 2t. So the integral of 1 is x. And the integral of cos 2t, it's one of the given integrals in the previous section. So, and it's actually equal with sine 2t over 2. Okay, so that's it. And now, so this is the capital F, so you have to evaluate it once at the point 0 and once at the point pi over 2. So if you evaluate it at, so let's say this is the capital F, so f of x. So if you evaluate it at the upper limit, which is 0, how much it is? I mean, it's 1/2 times 0 plus the sine of 0 over 2. The sine of 0 is 0. So that means that all of this becomes 0. And then you have to evaluate it at pi over 2. So the f at pi over 2, it's equal with 1/2 pi over 2 plus the sine. Now the sine of, let's write it, so sine of 2 pi over 2 over 2, so this cancels with this. So actually you have the sine of pi. So the sine of pi, it's again 0, so all this becomes 0. So the only thing is left is the 1/2 times pi over 2, which is pi over 4. So if you substitute it here, so that should be, I mean, the final answer will be 0, which is this here, minus pi over 4. So that's of course minus pi over 4. Okay, so now let's continue to problem 23, which I forgot to mention in the beginning. So problem 23 is to find the integral from, definite integral again, from 1 to square root of 2 of s squared plus square root of s over s squared with respect to s. Again, it's the same story. So first you have to find the integral, the antiderivative. So let's go and find it. So we have that the integral of s squared plus square root of s over s squared ds. So how much is this? I mean, here you have to make a small modification in order to be able to calculate this integral. I mean, what we do is we break the numerator, so that means that we can rewrite this as s squared over s squared plus square root of s over s squared. So this cancels with this. Of course, it's always the integral with respect to s. And now this here gives us 1 plus square root of s over square of s. So that's actually plus s. So it's actually to the 1/2 minus 2. So that's actually minus 3/2. So ds. So that's it. And now, this is the capital F of x. So you have to evaluate it at this point here. So you have to find the capital F at square root of 2. Sorry, here there is no more integral sign, because this here is the integral of this. So okay, so how much is the f at square root of 2? So just substitute it here. So that should give you square root of 2 plus this here we can write it 1 over s to the 3/2. So that should be 1 over square root of 2 to the 3/2. Okay. Okay, so and now let's see if we can work this a little bit. Let's work this a little bit. So that should be equal with, if we put here everything under the same denominator, so that should be square root of 2 to the 3/2 times square root of 2. So that should be square root of 2 to the square. So that here you will have only 2, and here you will have 1, and here you will have square root of 2 at 3/2. Anyway, this is just calculations. And now you have to evaluate this here at point 1. So let's do it. So the f of 1, it should be equal with 1 plus 1 over 1 to the 3/2. So that's equal with 2. And finally your answer will be this here. So your answer will be f of square root of 2 minus f at 1, always capital. So this will be equal with, so it's 3 over square root of 2 to the 3/2 minus 2. So yeah, that's it. We can leave it here. It's only calculations. So let's go to the next problem. So here they're asking us to guess what is the first of all, what is the antiderivative of the function that is inside. So actually of x cos x squared. So they're asking us to guess, to find the antiderivative of this, and then we have to find the definite integral, this definite integral from 0 to pi. And like they said that we should refer to the chain rule. So let's do it. So we want to find what is the antiderivative of this. So that means that whatever we find, if you take its, let's say that it's f, so if you take the derivative of this, it should be whatever you have inside. So it should be x cos x squared. Okay. So now, I mean, if you think backwards, the derivative of what is cos? It's actually the derivative of sine is cos. So let's start by that. So the f, it should include inside some sine. So a sine of what? Since here you have x squared, you should have x squared here too. Okay, so now if you try to take the derivative of this, okay, so if you try to take the derivative of this, we're not finished yet, but if you try to take the derivative of this, sorry, actually the f is equal with this. So now, if you try to take the derivative of this, it should give you this here. So let's try to find it. So the derivative of the sine, I mean, derivative of sine, of course, is, so f prime, it should be equal with, the derivative of sine is cos, so that means we put cos x squared, but you know, because this is a composite function of sine x, where x is x squared, so you have to use the chain rule. So you have to take the derivative of this function here, the x squared, which is actually 2x. So now, if you compare this here that we have with what we want to get, you see that everything is good, with the exception that you have these two here. So that means that we have to divide this function here by 2. So now if you take, again, just to confirm it, if you take now the derivative of this with, if you take the derivative of this, okay, with respect to x, so the derivative, I mean, you can take the 1/2 outside. So, and the derivative of sine x squared is equal with cos x squared times the derivative of this, which is 2x. So you see this cancels, so you have x cos square x, which is what we have here. So this here is the antiderivative. Okay, so this here is the antiderivative of this here. So and now again, you know, you want to find the definite integral, so you just have to evaluate it at pi and at 0.